Hello and welcome to the channel. Take the time machine and travel exactly half a century ago to the cold morning of January 19, year 1973. We are going to solve a problem very popular at that time. I only added two factors to make it less obvious, given that nowadays you can hardly separate anyone due to numerous math channels. And of course you can use only the tools available at that time to a high school student. Did you figure out a hint in my rather boring introduction? Anyway, I suggest you to pause the video and try to solve the problem on your own. Let P be the value we need to find. So we have 6 factors in the right hand side and all of them have 7 in the denominator. Let's make it 7 factors as well by multiplying both sides by sine of pi over 7. Would you like to continue from here? We've got sine times cosine of the same angle in the right hand side. And we know the formula for the sine of double angle. Apart from sine times cosine, the formula has factor 2. And we can get factor 2 for the right hand side of our equation by multiplying the equation by 2. So we do the multiplication. The left hand side becomes 2 times p times sine of pi over 7. And in the right hand side we replace 2 times sine of pi over 7 times cosine of pi over 7 by sine of double angle, 2 pi over 7. The number of terms in the right hand side has been reduced back to 6. Now we have factor 2 in the left hand side and factor 2 inside the sine. And again we've got sine times cosine of the same angle in the right hand side. And again we multiply the equation by 2 and apply the formula for the sine of double angle. Now we have only 5 factors in the right hand side. And again the factor in the left hand side matches the factor inside the sine. The pattern is clear, and it becomes obvious that by repeating the process we eventually get 32p times sine of pi over 7 in the left hand side, while the right hand side becomes sine of 32 pi over 7 times cosine of 32 pi over 7. For the last time we apply our magic trick and get 64p times sine of pi over 7 equals sine of 64 pi over 7. And we only need to find what sine of 64 pi over 7 really means. Dividing 64 by 7 gives 9 and 1 the remainder. Therefore, sine of 64 pi over 7 equals sine of 9 pi plus pi over 7. We know that 2 pi is the least positive period of sine function. Therefore, 8 pi is one of its periods. This means that we can happily drop 8 pi inside the sine, which leaves us with sine of pi plus pi over 7. According to one of the symmetry properties, this is negative sine of pi over 7. And we substitute that value into the right hand side of our equation. And since sine of pi over 7 is obviously non-zero, this means that p equals negative 1 over 64. So the answer is negative 1/64, or negative 0.015625. And this is the end.